What you're looking at is a reenactment of an actual event that took place at a dealership like yours. A technician spent over 5 hours trying to troubleshoot an ignition system complaint and never found the problem. Well, we've all been there. Ignition complaints can be some of the most difficult and time-consuming jobs that you can tackle. You can spend hours troubleshooting the bike and still not be certain that you found the cause. Well, you can try replacing the parts, but that takes time too. And if you guess wrong, you could be stuck with a $200 part that can't be returned. But it doesn't have to be that way. There is a tool that can dramatically simplify ignition system testing. In fact, many Honda dealerships already have it. It's called a peak voltage tester, and it provides ignition diagnostic information most multimeters can't. Information that can accurately pinpoint the cause of an ignition system complaint and eliminate guesswork and unnecessary parts replacement. Information that's so easy to interpret, you can make repairs and order parts with confidence. This technician spent 5 hours troubleshooting that ignition system and still came up empty. Unfortunately, it's a true story. The technician's frustration ended when the DSM pulled up with a peak voltage tester. Using the tester, the cause of the complaint was found in just 5 minutes. With a peak voltage tester, you can avoid wasting time like this, plus you can check the ignition system and pinpoint the cause of a complaint all in about 15 minutes. A little less for simpler bikes, a little more for bikes with bodywork. With a peak voltage tester, you'll be able to complete more jobs in a day, make more money, and have fewer comebacks. 3 good reasons to learn how to use a peak voltage tester. And if your shop doesn't have one yet, I'll give you a reason to buy one. Eventually, the majority of Honda service manuals will only offer peak voltage specs for ignition system troubleshooting. Resistance checks measured with a multimeter are being phased out. You're going to have to know how to use a peak voltage tester sooner or later. So why not make it sooner and start saving yourself a lot of time and aggravation now? In this program, we'll show you how a peak voltage tester can be used to quickly isolate the cause of an ignition system complaint and to identify what parts, if any, need to be replaced. After viewing this program, you will be able to identify the benefits of using a peak voltage tester in ignition system troubleshooting. Describe the function of a peak voltage tester. Define peak voltage and its importance in ignition troubleshooting. Measure ignition coil output voltage, spark plug firing voltage, ignition coil primary voltage, ignition pulse generator voltage, and exciter coil or battery voltage. You'll also be able to interpret the measurements. We'll demonstrate the 5-step test procedure on the DC CDI system of the TRX 300FW. Then we'll use a peak voltage tester to troubleshoot common complaints on the 2 other types of ignition systems. The AC CDI system on an XR250 that quits when it's hot, and the electronic type system on a CBR600F3 with poor acceleration. Lastly, we'll identify the conditions affecting the spark plug firing voltage. Now, I'm sure a lot of you are thinking, what does a peak voltage tester do that my multimeter can't? The answer is simple. A peak voltage tester tells you the peak voltage in the system. Well, it acts like an oscilloscope, showing you the actual voltage in the circuit at that moment. It's important to keep in mind that for an ignition component to work properly, it must have a minimum level of voltage. Only a peak voltage tester lets you know that you've got that minimum. There are specs that tell you what the minimum voltage should be so you know what you're looking for. And here's how simple the diagnostic part of the process is. If the component receives the right input voltage, it should deliver the right output voltage. If the output is too low, it's defective. Pass or fail. It's that easy. A peak voltage tester offers another advantage as well. It allows dynamic testing, making it easy to troubleshoot ignition complaints that occur while the bike's running or the engine's hot. Later in this video, we'll use a peak voltage tester to quickly troubleshoot a bike that quits and one with poor acceleration. But first, let's take a look at the tester itself. As you can see, this tester has 4 scales: 5 volts, 50 volts, 500 volts, and 25 kilovolts. Some newer testers go as high as 60 kV. This scale selection switch allows you to move among the various scales. Like any meter you use, be certain it's on a high enough scale for the test you're performing, or you could damage the tester. This tester has a switch that allows you to change polarity when conducting ignition coil output and spark plug firing voltage tests. This model also has low voltage terminals, 0 to 500 volts, and a high voltage terminal, 25 kilovolts. On this model, the on-off switch also has a battery test position, which is only used for the kV scale. When you move the switch to the test position, the indicator should light. If it didn't, I'd replace the two 9-volt batteries inside the unit. Here's the calibration screw. Always be certain the needle is calibrated to the 0 position before beginning a test. That's it. It's really a pretty simple tool. The only other things you'll need are the voltage specifications for the primary coil, the ignition pulse generator, and on AC CDI ignitions, the exciter coil. You can find these specs in the October '93 special edition of the wrench and the full cycle job aid that's designed to be inserted in the spec manual. And starting with the 1995 new model year service manuals, these minimum voltage specs are printed in the ignition troubleshooting section. Let's run through the troubleshooting sequence on a DC CDI system. Then we'll troubleshoot common complaints on an AC CDI and an electronic system. We'll use this simple 5-step test sequence. First, test the ignition coil output voltage. Second, test the spark plug firing voltage. Third, test the ignition coil primary voltage. Fourth, test the ignition pulse generator voltage. And fifth, test the battery or exciter coil voltage. Let's start with this TRX 300FW, which is equipped with a DC CDI ignition. We'll run the test sequence on this known good unit so you become familiar with the 5 steps. Normally, before you use the tester on an ignition system complaint, you want to check the battery. Is it charged? Are the connections clean and tight? The cause of a complaint could be right there. Okay, battery's good. Now let's use a peak voltage tester to check the ignition system. The first test will be for ignition coil output voltage. Remove the lead from the spark plug. Clip the black kV probe ground clip to a good engine ground. Insert the red end of the kV probe into the spark plug cap you just removed. Be sure the other kV probe is not near any metal part of the engine or frame. Plug the kV probe jack into the kV socket and select the 25 kV range on the meter. Make sure the fuel valve is turned off. Turn the ignition switch to the on position and the engine stop switch to the run position. Switch the tester on. Crank the engine and take a voltage reading. Switch polarity and crank the engine once more. Now, write down the higher of the two readings. Later, we'll compare this reading to the spark plug firing voltage. Here's a tip. If you didn't get a reading, check the spark plug cap and high tension lead. Next, we'll check the spark plug firing voltage. The black lead remains connected to ground. Now, connect the other kV probe and spark plug cap to the spark plug to complete the circuit. Crank the engine and take a voltage reading. Switch polarity and crank the engine again. Write down the higher of the two readings. The ignition coil output voltage, test number 1, should be greater than the spark plug firing voltage, test number 2. If it is, the entire ignition system is okay, and you can look elsewhere for the cause of the complaint. If the ignition coil output voltage is about the same as the spark plug firing voltage, or if there is no output at all, we would then test the primary voltage going into the coil from the ignition control module, or ICM. Disconnect the high voltage test probe and turn the tester power switch off. Then, reconnect the high-tension lead to the spark plug. The ignition coil primary voltage can be measured anywhere in the primary circuit. Well, as you can see, we removed the front fender for a better view. Switch to the 500-volt scale on the meter and connect one lead to the primary side of the ignition coil and the other to ground. Check the service manual to identify which color wires you're looking for. In this case, it's black, yellow, and green. Now, we just turn on the ignition switch and hit the starter button. As you can see from the service manual, we're looking for at least 100 volts. And we have it. If you get low or no voltage, reverse the test leads and check again. If the ignition coil is getting 100 volts of input from the ICM, but there is inadequate or no output at all to the plug, we check the spark plug wire and plug cap and test again. If the spark plug wire and plug cap are okay, the ignition coil's secondary windings are probably bad because the coil is receiving the 100 volts of input required, but is not generating sufficient output. Now, if you're not getting 100 volts input to the ignition coil from the ICM, you would move on and check the inputs to the ICM itself. Select the 5-volt scale on the peak voltage tester. To test the ignition pulse generator voltage, connect the special back probe adapters to the ignition pulse generator leads on the ICM harness. The service manual tells you which connections to use. In this case, we will first test with the positive probe at the blue-yellow wire and with the negative probe at the green wire. Make sure you've got good contact with the probes. Turn on the ignition switch, hit the starter button, and take the reading. If you don't get a reading, reverse the probes. The service manual tells us we're looking for 0.7 volts minimum. If we have a reading of 0.7 or more, the ignition pulse generator is okay, and it is. If we didn't get 0.7 volts, we'd need to pinpoint whether the ICM, the ignition pulse generator, or the voltage sensing wire is at fault. We disconnect the ignition pulse generator connector from the ICM and retest. If the ignition pulse generator produces an acceptable voltage disconnected, 0.7 volts or more, and the voltage sensing wire has 3 volts minimum, then the ICM is bad and should be replaced. If the ignition pulse generator still doesn't produce the required 0.7 volts when disconnected from the ICM, the ignition pulse generator is defective and needs to be replaced. This one's okay. The final test is the battery input voltage to the ICM. Simply check for battery voltage at the input circuit to the ICM. Looks good. If you don't have battery voltage at the ICM and the battery is charged and in good shape, the fault lies in the wiring, switches, or in the connectors between the battery and the ICM. Be sure to check for good grounds too. We've done the 5 simple tests using the peak voltage tester, and it's taken me just a few minutes to troubleshoot the entire ignition system on this TRX. Now let's use a peak voltage tester to troubleshoot a complaint many of you have had to deal with: a bike quitting when it's hot. The bike is an XR250R with an AC CDI ignition. Let's start by measuring the ignition coil output voltage and the spark plug firing voltage, then we'll compare them. As I showed you on the TRX, remove the lead from the spark plug. Clip the black KV probe ground clip to a good engine ground. Insert the red end of the KV probe into the spark plug cap you just removed. Plug the KV probe into the KV socket and select the 25 kV range on the meter. Turn the fuel valve off. Kick the engine over and write down the ignition coil output voltage. Remember to switch polarity and repeat the test, noting the highest reading. Now we'll check the spark plug firing voltage. Connect the KV probe plug cap to the spark plug to complete the circuit. Kick the engine over and record the spark plug firing voltage. Now compare the ignition coil output voltage you recorded with the plug disconnected to the spark plug firing voltage you recorded with the plug connected. The ignition coil output voltage, test number 1, should be greater than the spark plug firing voltage, test number 2.
If the ignition coil output voltage is the same as the spark plug firing voltage,
Or if there's no output at all, we would then test the ignition pulse generator voltage. First, place the meter where you can see it. Then, hook up the peak voltage tester as I explained earlier. Okay, we've got a reading of at least 0.7 volts, so the ignition pulse generator is okay. If you get less than 0.7 volts, you would pinpoint whether the ICM or the ignition pulse generator is at fault by disconnecting the ignition pulse generator connector at the ICM and retesting, just like we did on the TRX. Now remember, the customer said this bike quits running when it's hot, so we've got to duplicate this condition. Run the bike until it reaches operating temperature. Okay, here's the problem. The engine ran for a few minutes and then quit. I've disconnected the ignition pulse generator, and I'm still not getting the 0.7 volts we're looking for. That means the ignition pulse generator is defective and must be replaced. If the ICM input had been correct, I'd have moved on and checked the exciter coil voltage. In fact, I'll go ahead and do that because you haven't seen that test yet. The service manual gives you the minimum voltage for the exciter coil. In this case, it's 100 volts. For some other bikes, it may be less or it may be more, so always check the service manual. Set the tester to the 500 volts scale. Insert the tester probes into the connectors designated in the service manual. Here, it happens to be the black-red wire and ground. Now, kick it. 100 volts or more, and the exciter is functioning properly. If the exciter coil voltage is less than 100 volts, disconnect the exciter coil and test it separately. If it's still less than 100 volts, the exciter coil should be replaced. Just remember that a component such as an ignition pulse generator or an exciter coil can show an acceptable reading when cold, but an unacceptable reading when hot. That's why it's important to duplicate the conditions when you have a complaint that only happens when the bike is hot. Other conditions you can troubleshoot easily with the peak voltage tester are poor drivability and poor acceleration. Poor acceleration happens to be the complaint on this CBR 600F3. In fact, the tests we'd run are exactly the same as we did on the XR 250R a minute ago. When we're finished, we'll know for certain if the condition on this F3 is caused by the ignition system or by something else like the carburation.
start by checking the ignition coil output voltage at the spark plug cap of each cylinder with the engine cranking. Then measure the spark plug firing voltage of each cylinder. Remember to switch polarity during the tests.
If the ignition coil output voltage is greater than the spark plug firing voltage, you should look elsewhere for the cause of the problem because the ignition system is working properly. That's all there is to it. By the way, there are several conditions that will affect the spark plug firing voltage. They're listed in the job aid. For example, high compression requires a higher spark plug firing voltage than low compression. A lean mixture requires a higher voltage, while a rich mixture requires a lower voltage. Too much oil in the fuel mixture affects the spark plug firing voltage and increases the possibility of spark plug fouling. The more advanced the ignition is set, the lower the required voltage. The wider the spark plug gap, the higher the voltage required to fire the plug. The hotter the heat range, the lower the firing voltage. If the heat range is too hot for a given engine, the spark plug may cause pre-ignition, and of course, fouled plugs can affect the spark plug firing voltage dramatically. There may be carbon deposits on the center electrode insulator. This will cause the voltage to shunt to ground, and the engine will misfire or will not start. So if the spark plug firing voltage is not what it should be, these are the areas that you should check. I hope that over the course of the past few minutes you've seen how quick and easy a peak voltage tester is to use. It allows you to know for certain whether the component is good or needs replacing. The service manual gives you the minimum voltage spec for the ignition coil primary voltage the ignition pulse generator voltage, and the exciter or battery voltage. If it has the minimum voltage required or more, it passes. If it has less than the minimum voltage, it fails. Let's recap. In this video, we've identified the benefits of using a peak voltage tester in ignition system troubleshooting. We've described the function of a peak voltage tester. We've defined peak voltage and its importance in ignition system troubleshooting. We demonstrated the 5-test sequence using a peak voltage tester on the 3 types of ignition systems. Then we interpreted the measurements. Lastly, we identified conditions affecting spark plug firing voltage. The peak voltage tester can save you a tremendous amount of time. So why wait? Start taking advantage of the unique capabilities this tool offers today.